Hi, and welcome to the presentation of the Robbins 34R QRS. My name is Johnny Lili, and I'm product manager for race boring and mechanical rock excavation, which Robbins is a part of. We will talk more about that in the presentation. So we will divide this one into 4 parts. The introduction of race boring, main benefits, technical specification, then a very short summary. So let's start with an introduction of race boring. So not everybody knows what race boring is, so I will start with that, so at least you get a small understanding of the concept of race boring. So when drilling holes, this is what race boring is, drilling holes and drilling large holes. So that is normally done with the race boring method is done in 3 different variations. We have the conventional race boring, which means that you have the machine on one level and you're going to make a hole to another level. This could be from the surface down to the main shaft or main tunnel in the mine or in a road tunnel, or it can be between 2 different tunnels in the mine. That doesn't really matter. So conventional race boring, meaning that the machine standing on the top, you drill down using this drill string here, drilling down to the lower level. You connect a reamer and pull that one up. That's the name, race boring. You're raising the shaft. 99% of all the races is done in this way. It allows for very long holes, over 1,000 meters long, and diameters up to 8-9 meters. So it's a very effective way of doing long, large races. A variant of this called down reaming, and that, as you can hear on the name, is going downwards instead. You still need access to 2 levels, because you pilot down, you take the drill string up, then you put on an enlarger or a reamer that you enlarge on, and you push that one down, and all the cutting stands falls down through the pilot hole. Now you need this pilot hole here because you're normally using water or air to get the cuttings out when doing the pilot hole. But when doing a larger hole like this, there's a lot of volume here, so it's difficult to get the cuttings out that way. Therefore you need this pilot hole first. This method is normally used when it's not safe to access the lower level. Could be like a form of easer hole or slot hole for blasting against when you want everything to cave downwards. That's one example. The third method is called box hole boring, and that is done upwards. Now this can be done blind as we call it, meaning we don't need to drill a pilot hole first, but you have a pilot bit sitting in the front of the reamer and you're pushing the drill string upwards, all the cuttings fall down and is deflected by this muck chute here, or box, where the name box hole boring comes from. Goes out on the side. Normally not that long holes, maybe up to 50 meters. And this, you don't need access to the upper level. You can do it straight up in the ore body or what you want to drill in. These 2 methods is not that common as conventional, as I mentioned, but we're seeing more and more of this down reaming being done, especially in production drilling, where you need a larger slot hole to blast against. We have the machines called easer for this, for example. Now the reamer here, this is mechanical excavation, meaning we're not using any explosives or blast methods. So the reamer itself, it looks like this. So there's this big steel structure, and on that is a number of cutters. And these ones are pushed against the rock and then rotated. And then you can see that this cutter here creates these cracks. You can actually see these ones here also. And these are called curves. Now, this is the machine on top pulls the reamer and rotates it at the same time, creating this force. So the cutters are rolled over the surface. When the cutter here is rolled over the surface, there's a lot of small knobs sitting on here. Now, these knobs here pushes into the rock, and right under here you actually crush the rock. But what's happening when you push this knob in, you create a pressure bubble here, and you get tensile failures that creates cracks in the rock. Now, when you have two rows here, you have cracks from both sides coming, and when they meet, the rock ships out, and you have a curve breaking. And this is the principle of this. This is how you actually get an advance. Normal advance is about 2 to 3 millimeters per revolution, and the reamer spins about, depending on size, then but 10-15 RPM. So that's how race boring works. And the result then, this is the result. So you can see that you actually get a very smooth surface here. It's excellent for ventilation. There's very little friction in this. And this is what race boring mostly is used for, ventilation shafts. But it can be used for other things as well. So hoisting, slot holes that we talked about earlier. The smoothness is one good thing